Hi, a pleasant day to all. Today, we will start a new topic, which is on environmental chemistry. As an environmental advocate, this is the topic that I'm very much interested to share with you. And I hope that by the end of this lecture series on environmental chemistry, there will be more of you who will be joining me in environmental advocacies. So let's start. Okay, so environmental chemistry. So this is the study of sources, the reactions, the transport, the effect and fates of chemical species in water, in soil, or in air and the living environments, including the effect of technology. Um, the environments that we are living in consist of five major spheres. One is the atmosphere. So atmosphere comes from the Greek word atmos, meaning vapor. And we have hydrosphere from the Greek word hydro, meaning water, and geo from the Greek word meaning um, earth. So geosphere is also known as the lithosphere. And we have the biosphere from the Greek word bios, meaning life. And we have atmosphere from the Greek word anthropos, meaning human being. Okay, so um, I'm asking you this question, why study environmental chemistry? So we might have this different opinions with this, but I'm very interested to know on your opinion and why study environmental chemistry. So I'll be posting a link on wherein you can key in your answers to this, and your classmates will be able to view it or like if they want to like your comments or your meaning your answer to this, why study environmental chemistry. So just be updated with our postings on this related to this question. Okay, so environmental chemistry, there is an exchange of a huge quantities of materials and energy among the five spheres of the environment that when understood and harnessed, they can be utilized for the benefit of the society. So, let's look in closer to the atmosphere. So um, as the the distance increases from the Earth, the temperature changes from 15 to negative 56 to negative 2, negative 92 to 1,200 degrees Celsius. So the atmosphere is divided into several layers on the basis of temperatures. So we have troposphere, stratosphere, mesosphere, thermospheres, and exospheres. So in the troposphere, this is where all the weather-related phenomena occur. So ranging from negative 56 um, to 15 degrees Celsius. So when there is a typhoon, weather disturbance, this is usually happens in the troposphere. And then stratosphere, this layer. So the stratosphere, it is where the ozone is located, and it ranges from negative 56 to negative 2 degrees Celsius. The mesosphere, this one, it is where this is where the meteor burns up as they enter the Earth's atmosphere, ranging from negative 92 to negative 2 degrees Celsius. And then the thermosphere. So the thermosphere, this is where the auroras occur and where the International Space Station is situated, ranging from negative 92 to 1,200 degrees Celsius. So in places where in some other parts of the earth, of the world, they are very fortunate to witness this aurora occurring. And then the exosphere, this layer, little is known about this layer, and it has a very cold temperature here. Okay, so we know that the atmospheric air consists of nitrogen, which is 78%, and oxygen is 21%. The remaining 1% comprises of the noble gases and some of the gaseous materials. Some of those are argon, carbon dioxide, neon, helium, krypton, xenon, which comprises of 1%. Now, photochemical reaction. So what is photochemical reaction? This is the chemical reaction that results from the involvement of electromagnetic radiation from the sunlight that are called photochemical reactions. Let's have an illustration. So let's have this example of the photo dissociation. So imagine sa mga may love life dyan, imagine this oxygen, two oxygens banded together. They have relationship. And here comes the third party, which is your electromagnetic radiation coming from the sun. So sabi ng electromagnetic radiation, magbe-break din kayo. So what happens when electromagnetic radiation comes in? So there is it interacts with the oxygen, the diatomic oxygen, and it causes it to dissociate. So it breaks down. So umiiyak ang dalawang oxygen dahil nag-break sila. So I don't know if some of you can relate to this. No, this is just for the sake of illustration. So an example is when the atomic oxygen O2, this one, O2, there is two oxygen banded together. It dissociates to individual oxygen atoms after absorbing the electromagnetic radiation. So photoionization. So this happens when an atom loses a valence electron, thus becoming positive, or in other words, ionized. So electron is dislodged, and then so the atom loses its valence electrons here. So that's why it becomes more positive, or it is ionized. Now let's look into the ozone formation. So how ozone is formed? So there is again the action of photochemical reaction happening here. So you have your oxygen, and the electromagnetic radiation cause it to dissociate into oxygen, free oxygen. So this free oxygen can interact either of this, or can both of this. They can find another diatomic oxygen, which they can interact with to form ozone, or O3. No? So after O2 is dissociated into two oxygen atoms, the newly freed oxygen is now free to bind to O2 to form O3. Of course, when there is ozone formation, there is also oxygen destruction happening. So when ozone interacts, when the electromagnetic radiation comes in contact with the ozone, or your O3, it dissociates into O2 and free diatomic oxygen and monatomic oxygen. So the O3 may also absorb electromagnetic radiation that causes it to dissociate into O2 and oxygen atom. So here, your freed oxygen can also interact with another ozone, which can when they interact with ozone, it can form oxygen. It um, um, can dissociate. I mean the oxygen, the one oxygen here can be can be um, um, can be taken away from this molecule, and then it interacts with another oxygen. So that's why they form um, the atomic oxygen. So the free oxygen atom can continue to bombard the ozone molecule to form two diatomic molecules. So if the destruction of ozone is faster than its formation, this may result to the depletion of ozone layer. So as you can see, this is a natural phenomena happening in the Earth. So because Earth is exposed to the sun, to electromagnetic radiation. So this is a natural process. Now the problem comes in if the destruction of ozone is faster than its formation. That is, when that happens, there will be ozone depletion in the ozone layer. So this is a natural phenomena happening in the Earth atmosphere. Now, what role do humans play in the formation or destruction of ozone layer? So human activities can produce substances that can lead to ozone destruction. So one example of this is your chlorofluorocarbon or your CFCs. So when your chlorofluorocarbon when electromagnetic radiation strikes your chlorofluorocarbon, your chlorine will be freed. No, so this chlorine can interact with these free radicals. Your chloride can interact with your ozone. So again, your chlorofluorocarbons in the atmosphere, it can absorb electromagnetic radiation, resulting to its dissociation, wherein chloride is being freed. So here comes your chloride and interacts with your ozone in your atmosphere. So it binds with your oxygen, and then there is the atomic oxygen is being released also. So the chloride or your free radical proceeds to bombard the ozone molecule, causing it to dissociate. So this is where the ozone layer depletion happening when this chloride, your free radicals, bombard the ozone molecule. So this process is a continuing process. So your chlorine and oxygen molecule here can again interact with a free molecule, wherein the chlorine again is being freed. So this second reaction result to a more free radicals that will result to the first reaction. So this cycle is how the CFCs produced by human it contributes to the ozone layer depletion. So this is a chain reaction. It keeps on repeating. It keeps on repeating until mag-stabilize ang mga molecules ng chlorine. And mag-stabilize ang interaction ng chlorine in the atmosphere. No? Makahanap siya ng partner talaga na mag-steady na siya doon. All right, so let's have a homework. I want you to read on the greenhouse effect and what compounds are considered greenhouse gases. So you may research on this one and let me hear your what you have read about this greenhouse effect during our synchronous meeting. Right, so let's move on to green chemistry. So I believe you have heard about green chemistry. So what are these green chemistry? So green chemistry, it is the design of chemical products and processes that aims to reduce or eliminate the use of or the generation of hazardous substances. It is also known as sustainable chemistry, and it applies throughout the life cycle of a product, from its design, from the manufacture, use, until its disposal. On the other hand, cleanup technologies aims to clean up pollution produced from all sorts of sources. So something to think about. So how is green chemistry different from simply cleaning up the pollution? So green chemistry looks at the three things. One, the economics. Green chemistry should aim to be less costly compared to the existing technologies. So take note of the word less costly. Another one, green chemistry should operate efficiently such that there is maximum yield, maximum recycling, and minimum use of virgin raw materials. And then the waste. Green chemistry aims to reduce the waste, or if at all possible, completely eliminate production of waste, if possible. All right, very famous word in environmental chemistry or in environmental protection, recycling. So there are two types of recycling. One is high-level recycling. It uses less energy and materials and conserves the materials' embedded utility. So another one is the low-level recycling, wherein it uses more energy and materials. Okay, so the question is, why recycle? Why do we need to recycle? Recycle reduces waste sent to the landfills. So your solid waste, or other type of waste has some value in it. So that's why we need to recycle. And by doing that, we can reduce the waste sent to the landfill. So yung dinadalan lang sa landfill are those residual waste, wherein those waste have no, you can no longer use this waste. So by recycling, we reduce the waste sent to the landfill. And it conserves natural resources, of course. And it prevents pollution as well. It saves energy, and it helps create jobs in recycling and manufacturing industries. There are manufacturing industries who are expert on recycling, from monoblocks, from bags, from fuels. No, there are several industries that do recycling. Even now, the oil is very famous. So there are types of there are manufacturing industries who recycles your used oil or even your cooking oil, used oil, cooking oils. Now they turn it into biodiesel. All right, so I think that's all for the introduction part of our environmental chemistry series topics of that we're going to tackle with. So that's all for now, and see you in our next topic. Bye.